Geiger-Müller counter in nuclear physics. It is commonly used in nuclear physics laboratories for the detection as well as the measurement of ionizing radiation. The device is invented by the scientists Geiger and Müller in the year 1928. Let us move to the construction part. Then let's see the principle. Here in the construction we have chamber C which encloses gas inside it, and the chamber is connected to the negative terminal of the battery, and the tungsten wire W which is stretched along the chamber, along the length of the chamber, is connected to the positive terminal of the battery through a load resistance R, and the chamber and the tungsten wire W are insulated by means of a ebonite flux E on both the sides. Now when the alpha particle enters the chamber, the gas molecule inside it will split into two particles, that is positive ions and negative electrons. So these positive ions will be attracted towards the chamber which is connected to the negative, and the negative electrons which are attracted which will be attracted towards the positive terminal of the W. So once the alpha particle enters the chamber, the gas molecule inside it split into two things. One is positive and ion, and another one is negative electron. Positive ion will be attracted towards the chamber, and the negative electrons will be attracted towards the W, that is tungsten wire. A small potential difference will be developed. So when these electrons travel towards the W, these may collide with the further gas molecules, and these may produce so many number of positive ions and negative electrons. So that process is known as secondary ionization process. So once the alpha particle enters, the primary ionization occurs. During its movement towards the electrodes, those may create a secondary ionization process because of collision. So many electrons, avalanche of electrons will be created. So that will develop a current pulse across this. So now we could measure the entry of ionizing radiation by means of a current pulse produced here. Now let us move to the principle. Here the primary principle here is ionization, that is ionizing when the radiation enters in the gas tube. So that will produce ions and electrons which will create a pulse of current that can be counted, that can be detected, and that can be counted. So to summarize what we had seen, I am going to summarize as a working. So the radiation enters, that is alpha particle enters the chamber. So the gas molecule ionizes. Ionizes means it splits into positive ions and negative electrons. Those electrons will be attracted towards the anode, the W, causing secondary ionization. So large number of electrons, avalanche of electrons will be produced at the anode and produces a voltage pulse. Each pulse will be counted as a one current. Each current pulse will be counted as a one count. So the counting depends on the voltage. So let us see the voltage count per minute relationship by means of this characteristic curve. So initially the tube will not work once the initial voltage above 100 volt if we supply means, then only the tube will start to work. So that voltage, the initial voltage which required to start the tube is known as threshold voltage. So after that, when the voltage increases, the current also increases. So this is known as the proportional region, that is voltage and current are in linear manner, that is proportional manner. And here this is the region known as plateau region, where the voltage is independent of the count. So see, the voltage increases but the current is almost constant, that counting rate is almost constant. So this is the plateau region, this is the working region. And the next beyond a certain voltage, if even for a very small increase in voltage, the tube will break. So it is this region to be avoided. The tube should not be worked in this region. So only this is the recommended working region. So that's what about GM counter. So ionization process, so many electrons and positive ions will be created. So the potential difference here is counted as detected as a current pulse. Thank you.